So hello everyone. In today's lecture, we are going to solve some more problems related to complex number. Got it? So let's look at this problem. In this problem says that Z belongs to complex number and the real part of 1 upon Z is smaller than 1 upon 2. Find the locus of the Z. So for this kind of problem, we'll solve by keep Z as x plus iota y. Now they've given that the real part of 1 by z, right? So first we'll calculate what is 1 by z. So 1 by z will be equal to 1 upon x plus iota y. So now we'll rationalize. Upon rationalizing, we'll get x minus iota y will multiply up and down. X minus iota y, numerator and denominator will multiply. So after multiplying, we'll get in denominator x square minus iota square y square, and in numerator x minus iota y. Got it? So here we will get iota square is minus 1. So here we will get x upon x square plus y square minus iota y upon x square plus y square. This is my complex number 1 upon z. This is my complex number 1 upon z. Now in the question they are saying that the real part of this complex number is smaller than 1 by 2. So we'll apply the condition. The real part of this complex number, the real part of this complex number 1 by z is smaller than 1 by 2. Now tell me, what is the real part of this complex number? The real part of this complex number is x upon x square plus y square. So we'll keep here x upon x square plus y square is smaller than 1 upon 2. Now we'll cross multiply, as this side x square plus y square is positive, so we can we can send this to that side, and this 2 is also positive, so this 2 we can send to this side. So here we'll get 2x is equals to, sorry, not equal to, 2x is smaller than x square plus y square. So if we'll send 2x to that side, we will get 0 is smaller than x square plus y square minus 2x. Or you can write this as x square plus y square minus 2x is greater than 0. Got it? So now if you'll see, what is this? This is actually the equation of a circle, right? This, what is the center of the circle? The center for the circle is 1 comma 0, right? Minus g comma minus f. What is g? G is the half of the coefficient of x. So minus g is plus 1 comma 0, and radius is under root of g square, which is 1 square, plus f square minus c, all are 0. So here we'll get simply what? Radius is 1, center is 1 comma 0. So if we'll plot this circle, we'll get a circle whose center is 1 comma 0, 1 comma 0, and radius is 1. Radius is 1 units. This is my coordinates of circle. Center of the circle and radius is 1 units. Now they didn't say this equals to 0. They said greater than 0. Greater than 0 means it represents the region outside this circle. All the complex number lying outside this circle comes in this equation. So what is the locus of z? The locus of z is all the complex number lying outside this circle with center 1 comma 0 and radius 1. Got it? This question is done. Now next they've given one more question, that find the complex number z. We have to find the complex number z, and for this z they have given two information. The first information is argument of z is pi by 2, 90 degrees, and they've given z minus 3 iota, mod of z minus 3 iota is equals to 3. So this will represent a circle This will represent a circle with center 0 comma 3 and radius 3. And what does this represents? This represents a ray originating from starting from origin. Got it? If you have any doubt how this equation is representing a circle, or how this argument of z is equal to pi by 2 is representing a ray, I explained this in the previous videos. Please go and watch that video. After that, you'll have a clear concept on how it is come. So now next, we'll see next. Here we'll draw first this circle. Second equation represents a circle with the center 0 comma 3. 0 comma 3 lies somewhere here, and radius is 3. So this is a circle represented by this equation. It will touch x-axis because radius is 3 and center is at 0 comma 3. So this distance is 3 units only. Now next, argument of z is equals to pi by 2. This will represent a ray. This will represent a ray starting from origin. Take some different color. It will represent a ray starting from origin, and as argument they've given pi by 2, that means it will go along the y-axis like this. This array is represented by this equation. Now they're asking complex number z. Complex number z satisfies this equation also and this equation also. That means the point of intersection of these two graphs is my complex number z. So now tell me at how many points it is intersecting. It is intersecting at only one point, because at this point there is an open circle on ray. This represents a ray excluding origin. It is starting from origin, but origin is not included. After origin it is coming, so xy axis is coming. Got it? So here, so this coordinate, this is my complex number z. What is the coordinate of this point? The coordinate of this point will be 0 comma 6. So the required number z is equals to 0 plus 6 iota, or z is equals to 6 iota. Now next, so we'll see this question. In this question they gave that z is a complex number satisfying the equation z minus 25 iota smaller than equal to 15. Then find the complex number z having the positive argument. So first of all, we'll look into this equation. Tell me how many complex number are there which will satisfy this equation. There are infinite number of complex numbers satisfying this equation. Out of that complex numbers, they're asking which complex number has the least positive argument, means the smallest positive argument. Got it? So first we'll see, first we'll draw the locus of this equation. It will represent a circle, right? It will represent a circle. What is the center of that circle? The center of that circle is 0 comma 25. The center of the circle is 0 comma 25, suppose here. And what is the radius of the circle? This is the circle. The center is 0 comma 25. Center is 0 comma 25 and radius is 15. Center is 0 comma 25 and radius is 15 units. Got it? Now next, they have given that z minus 25 iota mod is smaller than equal to 15. Smaller than equal to 15 means it represents all the points lying on this circle and inside this circle. Lying on this circle and inside this circle. It represents all the points lying on this circle and inside this circle. Now next, now out of these all complex number, which complex number will have the smallest argument? So if I'll see, Argument means we'll measure after joining that complex number with origin. So we'll join any complex number with origin and we'll see. Suppose this is a complex number. Got it? This complex number. This complex number will make this much angle theta. If I will draw, except this, if I will draw any other complex number, suppose I will draw this complex number. This complex number argument will be, this is the argument of this complex number. For any other complex number, if I will join with origin, the argument will be bigger. So this, the line coming from origin and which is tangent to the circle on this first quadrant will be the smallest will be the complex number which is having the smallest positive argument. Got it? So we have to find this complex number z. This is our required angle, this point. Now next, how to find this? To find this, we will join the center of the circle and this line. Now tell me, what is the length of this blue line? The length of this blue line will be 15, right? Because radius is 15. Now next, if this angle is theta, this angle is 90 minus theta. If this angle is 90 minus theta, this angle is 90 because it is angle between the radius and tangent, which is 90. 90 minus theta, 90. So this angle will be theta. This angle will be theta. Now next, if this length is 15, this complete length is how much? This complete length from origin to the center of circle, it is clearly 25. So this height is 25. So now next, if we'll apply Pythagoras theorem, the length of the tangent, we'll mark this point, I'll mark as A, this point I'll mark as B, and this point I'll mark as origin is O. Now next, if we'll apply Pythagoras theorem, we'll get AO square plus AB square will be hypotenuse square. Hypotenuse is OB. So from here, what is AO square? AO square we don't know. We want to calculate AO square, and AB square else into that side. What is the value of AB? AB is 15. So I'll get here. And what is the value of OB? OB is 25. So here I'll get 25 square minus 15 square. So AO length will be equal to under root of 625 minus 225. So AO will be equal to under root of 400, which will give 20. So AO length is how much? AO length is 20 units. So 20 units. Now next, length we know 20 units. Now can you tell what is the form? What is cos theta here? Theta is this angle, right? This angle is theta and this angle is also theta. So now using this right angle triangle ABO, we'll find cos theta. So cos theta value will be equal to adjacent or base upon hypotenuse. So here we'll get 15 upon 25, which is equals to, we'll cancel with 5, we'll get 3 upon 5. Now next, what is the sin theta value? Sin theta value will be equal to opposite or perpendicular upon hypotenuse. So here we'll get 20 upon 25, which is 4 by 5. Now, what we got? We got something like this. We got the length of this line segment, and we got this angle theta, cos theta and sin theta value we got for this angle theta. This angle is theta, the length is 20, and we want this point coordinates. This point coordinate is our answer. The coordinates of A. The coordinates of A only is my required complex number. So here we'll get, so we'll resolve this one on x-axis and we'll resolve this one on y-axis. So what is this length? This length will be equal to A cos theta, OA cos theta, and this length will be OA sin theta. So now next, what is OA cos theta? OA is 20. OA is 20. Cos theta is 3 upon 5. So this will be equal to 12. What is OA sin theta? OA sin theta will be equal to 20 multiplied by 4 by 5. This is 16. So my required complex number is My required, so A coordinate is 12 comma 16. So my required complex number Z is, my required complex number Z is 12 plus 16 iota. 12 plus 16 iota.